Hi, I'm Sean Kipkemboy. Today I will walk you through my bank application project. I will explain how it applies object-oriented principle, demonstrate the key scenarios, and reflect on its extensibility. Welcome. First and foremost, let's dive into the overall solution. The BankApp is a simple account management system. It lets users create account, deposit, withdraw, transfer funds, and print transaction history. It has four main parts: account that stores balances, bank manages accounts and transactions, the transaction hierarchy defines deposit, withdraw, and transfer, and finally, we have the program that provides the menu and inputs validation. Here is the flow. The user inputs data, transfer is then created, bank executes the transaction, and finally, the result is stored and displayed to the user. Let us know where abstraction and encapsulation is used in the bank app. Abstraction is applied through the transaction abstract class, which defines what every transaction must support, such as execute, rollback, and print. Concrete types like deposit and transfer simply implement this. Encapsulation is the process of protecting the data. For example, an account balance is private and can only be changed through deposit or withdraw method, which validates amount and prevents invalid states. After understanding where abstract and encapsulation is used, let's dive into inheritance and polymorphism. Inheritance is seen in deposit transaction, withdraw transaction, and transfer transaction. All extend the transaction base. Transfer even composes withdraw and deposit internally. Polymorphism is used when the bank stores a list of transactions. It calls execute or print on each without knowing which specific type it is, letting different behaviors run through the same interface. Now, let us see how the bank application program handles errors and maintains data integrity. The app validates user inputs, whereby deposits must be positive, withdrawals cannot exceed the bank balance, and at the same time, transfers must be between different accounts. Inside the domain classes, rollback prevents inconsistent states. For example, if the transfer deposit fails, the withdrawal is rollback. Let us now check the class diagram. The design can be summarized visually, whereby the bank contains account and transactions. Transaction is an abstract class with execute, rollback, and print. Subclasses include deposit, withdraw, and transfer. Transfer uses both a withdraw and a deposit internally. This shows the relationship of composition and inheritance clearly. Now let us see a simple demonstration plan of how our bank application works. In scenario A, a user can create accounts, can deposit funds, can withdraw funds, can transfer, and print transaction history. In scenario B, this one is where we have an invalid operation such that over withdraw, negative deposit, and self-transfer is not allowed. This highlights polymorphism and rollback behaviors. Now, let us see how we can improve our program and see how the reflection and extensibility of our bank application program. This program is extensible in such a way that new transaction like fee transaction or interest transaction can be added easily. The program could be replaced easily with graphic user interface or web application without touching the domain classes. Future improvements include adding persistence of database or file storage, logging in, and unit testing. In summary, the bank app has demonstrated fully the abstraction, encapsulation, inheritance, and polymorphism in clear and extensible design. Thank you and welcome again for my presentation. Here is my account class. Thank you. The next one is a transaction class with a public abstract transaction, public decimal amount get, rollback, execute, and print transaction. Thank you. Finally, we have a sample code of transfer transaction that I used in my program. That is public class transfer transaction. We have a public override void. And you can just say over it, and it's clearly demonstrate how the transfer transaction class really was. Thank you. And any question?